Welcome back to the Trade Sailor project. Today we're going to start the first design. We're going to start with defining the start point. So we're going to start with the definition phase. This is the first step of the actual starting of the design. Till this far we've done the introductory stuff, but today it's starting of designing. So what's the definition? The definition is preparing the start point. So understanding what we actually really want to design and giving that some dimensions and some boundaries. So the definition phase is, we call it the foundation of the design. Any points you set here is your start point, and the better you can get your start, the less steps you need to finish the design spiral. If you get your definition wrong, or you don't understand the actual design very well, you might need a lot more effort to get to the end point. We're gonna find out what the purpose is, so what actually we're designing and what do we want it to do. And we're going to end with some main dimensions. We're going to continue with the rest of this iteration. So what's actually in the definition phase? So first, of course, it's very important to determine what the use is of the vessel. Is it going to hop along the coast? Is it, we're going to cross oceans? We want to take frozen goods, containers, etc., etc. The second one is constraints. Are there any restrictions on the vessel, lengthwise, beam-wise, height-wise, draft-wise, etc., etc.? And the last one is the setting of the basic dimensions, and I'll show you which basic dimensions I've determined for the starting project. So what's the intended use? For this project, for this first vessel, I'm looking for a coastal and inter-island trading ship. So hopping along the coast from harbor to harbor, or sailing from island to island in a group of islands. Or from the mainland to islands, etc. We're looking at transporting break bulk, pallets and containers. It has to be easy to build for less advanced yards. So a yard that can build a simple fishing vessel has to be able to also build this sailing vessel. So for this project there are not many constraints. We're at sea and we don't have a demanding client. We're our own client. I set myself a few limitations. Maximum length overall of 13 meters to keep the project small and small investment. Multiple cargo types, containers, pallets and break bulk. We have dimensional heights, etc. not really restricted, so we're very free there. For a crew, a minimum crew, maybe 3 or 4 people, probably 4. And a complexity very simple, so it has to be able to be built by a simple yard. So a yard which can build steel fishing boats should be able to build this boat as well, and easy to operate. So no difficult furling systems, etc. Simple operation, simple maintenance. So to wrap up the design brief, has to be simple to build by a yard, easy to operate by minimal crew, easy to troubleshoot and maintain. So no difficult systems. Able to unload cargo without shore crane, so it's easy when you're at an island which doesn't have any harbor facilities. Maybe you even use lighters like Norfolk Island. Then you can you should be able to offload the cargo, so the pallets or the break bulk, except for containers. That gets for this size too difficult. And it's also not logical. If they use containers, there will be a container crane. Worst case, a mobile crane. Cargo type, so like I said, operational area, so coastal, inter-island and open ocean. Open ocean I did if they have to sail to a faraway island, part of it will be open ocean. So materials, I envisage a steel hull and an aluminium deckhouse. So a steel hull to keep it simple and cheap to build, and the aluminium deckhouse to give electronics, etc. a bit of and compasses, less interference. And for the auxiliary propulsion, electric propulsion with regeneration. So when they sail, they can charge the batteries again. So this is the basic design brief. Now let's go on to the main dimensions. So for this project, I looked at a whole heap of reference ships. There's actually quite a few sailing cargo vessels, old style and a few modern style as well. And I put those in a database, and from that I can extract curves, so I can see the groups and how they relate to each other, and I can see how my proposal relates to them. And this way I get a good set of data, which will be a lot closer to the finished product than when I had to just make it all up out of thin air. So from all the reference ships, I extracted the following set of basic dimensions, and this is the starting point. So these are what I will use in the next steps to as my starting point for the first iteration. So I've got a length overall of 30 meters, a length waterline of 28 meters. I've got a beam of 7.1 meters, displacement of 325 cubic meters, a sail area of 450 square meters, 4 crew, and a cargo capacity of 130 tons, and I should have space for 4 20 equivalent units, or 4 20-foot containers. So the main dimensions we determined in the previous slide, I'm going to use this week to create a new first iteration hull in 3D and in the deck as well. Yes, so let me know what you think. What should the hull be? Should it be round build? Should it be double-ended? Should it be have a big transom, wide at the back, narrow at the back? Let me know in the comments of this video, and then I'll add it to the design of next week's episode. Hope to see you next week. Bye.